Today's lesson is going to be on polynomials, specifically adding and subtracting. So before we get into how to add or subtract, first we're just going to review the definition of a polynomial. So a polynomial is an algebraic expression with one or more unlike terms. The standard form of a polynomial is basically descending order, but we always simplify first. So you would want to make sure that all like terms are combined, and then you would put it in descending order of the exponents. So our first example, 2x to the third power, or 2x cubed minus 4x squared plus 9x minus 3, is 4 terms. So that's called a polynomial because 4 is more than 1. And it's a third degree polynomial because the highest exponent shown is 3. It's also in the correct order, called standard form. Our second example has to be changed. First, we're going to combine the like terms of 4x and 2x, and then we're going to put it in the correct order. So that would be 9x to the fifth minus 5x squared plus 6x minus 8. That would also be 4 terms, but the degree would be 5 because the highest power shown is a 5. In order to add or subtract, it's basically an extension of combining like terms. We consider terms like when they have the same exact variables, which are the letters, to the exact same power. So examples of like terms would be 2x and 4x, 3x squared and negative 9x squared, 2a squared b and 4a squared b. You'll notice the only thing different about the terms is the coefficient, which indicates how many of each term there are. Things that are not like terms would be 2 things with different letters, or something with a letter and something without, or the same letters but to different powers. So if you notice on the last example, the b is squared, and on the other one, the a is squared, which makes these unlike or not like terms. Basically, if you have like terms, you can add them just by counting up how many there are. So if you have 2 on one and 3 in another, put the 2 and the 3 together and you get a total of 5. And that's simple. It's just really counting or adding the coefficients. So to combine the like terms, you just want to first of all figure out if they're like or not. So an x cubed is like an x cubed, so you would just add the coefficients. So 4 minus 2 is 2. Again, it's the same letter with the same power. So the x's would go with the x's and the y's would go with the y's. So 2x plus 8x minus 4x gives us 6x. And then negative 7y minus 12y gives us negative 19y. Remember, it's just counting. So it's like I have 2, I have 8, but somebody took 4. All right. Again, it's like terms. So we're going to do the 2x squared with the 3x squared to give us 5x squared. We're going to do the negative 12x and the positive 3x to give us negative 9x. And the negative 7 and the negative 6 to give us negative 13. Our first example is 1 term. That's called a monomial. Our second example is 2 terms. That's called a binomial. And our third example has 3 terms. That's called a trinomial. In order to add polynomials, it's really basically the same as adding monomials. It's just more than one. I like to line them up. I think of old school addition where you would line them up like the hundreds with the hundreds, the tens with the tens. You want to add only like with like. And remember, only the coefficients should be different. So it's the same variable, same power. You never, ever, ever change an exponent when you're adding or subtracting. And then write your answer in descending order. So example 1 on our paper is find the sum of 2x squared plus 3x minus 7 and 4x squared plus 12x plus 6. So one thing you can do is you can rewrite them where you're putting the x squareds with the x squareds, the x's with the x's, and the constants with the constants. Or you can also just do this with your finger. All right. So we have 2 plus 4. They're both x squares. We have 3 plus 12. They're both x's. And then we have negative 7 plus 6. So that's going to give us 6x squared plus 15x minus 1. Our answer is a trinomial. Example 2. Find the sum of 4x squared minus 3x minus 7 and 3x squared minus 2x plus 16. So again, one idea is to line them up, and then you just add the like terms with the like terms by adding the coefficients. So 4 plus 3 is 7, negative 3 minus 2 is negative 5, and negative 7 plus 16 is 9. So our answer is the trinomial 7x squared minus 5x plus 9. Example 3. Find the sum of x squared minus 7, 3x squared minus 2x plus 5. So when I write my x squared minus 7, I leave a gap or a space for where the x would be if it was there. If it helps, you could always make it a 0x. I don't think you'll need it. You can just leave a gap, which would indicate there's nothing there. Since there is no exponent shown, no coefficient shown, it's always a 1. So 1 plus 3 is 4. 0 minus 2 is minus 2. Negative 7 plus 5 is minus 2. So we get 4x squared minus 2x minus 2. Okay. This can also be applied to perimeter because remember, perimeter is just adding all the sides. So the first thing I would do is use the properties of a rectangle. In a rectangle, opposite sides are congruent, so you can use that to find all the sides. So once you fill in all the sides, you're just going to add the like terms, 2x squared, 4x squared, 2x squared, and 4x squared again. The 3x with the 3x, and the negative 6 with the negative 7 twice. You end up with 12x squared plus 6x minus 26. So adding is really just combining like terms, but there could be 4, 5, 6 terms in one question. Subtracting. So we use the definition of subtraction being adding the opposite. And when you subtract, it's just like 4 minus 2 is 2. But if you have more than one term being subtracted, you have to distribute the negative to all the terms. I again line them up. And of course, you never change an exponent when adding or subtracting. I always write my answer in standard form, which would be descending order. But remember, this is subtracting, so you have to be careful. You have to make sure you distribute that negative. Otherwise, you're just adding. Okay, so here's example 1. When I rewrite this, I'm going to keep the 2x squared, the 3x, and the subtraction 7 the same. But I'm going to distribute a negative 1 to everything being subtracted. So the positive 4x becomes a negative 4. The positive 12 becomes a negative 12. The positive 6 becomes a negative 6. Once you do that, you've now made an addition question. So you change subtraction to adding the opposite. The opposite is the same number with a different sign. Once you do that, you just add them together. So 2 minus 4, 3 minus 12, negative 7 minus 6. You get negative 2x squared minus 9x minus 13. Example 2. Find the difference of 4x squared minus 3x minus 7 and 3x squared minus 2x plus 16. Copy the first trinomial. Change the sign of everything being subtracted. So the positive 3 becomes negative 3. The negative 2 becomes positive 2. The positive 16 becomes negative 16. Now you have an addition question. So you add 4 plus -3, or 4 minus 3, -3 plus 2, -7 minus 16. And you get x squared, or 1x squared if you want to put the 1, minus x minus 23. Example 3. Find the difference when x squared minus 7 is subtracted from 3x squared minus 2x plus 5. When you subtract from, the from comes first. So the 3x squared minus 2x plus 5 is going to be on top. Then you change the signs of everything being subtracted. So I change the sign of the x squared, I change the sign of the -7, and now it's an addition problem. 3 minus 1 is 2, the -2 plus 0, and the 5 plus 7. So you get 2x squared minus 2x plus 12. Example 4. The difference between 9x squared plus 3x minus 7 and 4x squared minus 6. So again, you're going to change the signs of everything being subtracted. So I changed the sign of the positive 4x squared to negative 4x squared, and the sign of the -6 to positive 6. Be careful with subtraction. The order matters. So you do have to know what's being subtracted. And then it's just 9 minus 4, 3 plus 0, and -7 plus 6 to give us 5x squared plus 3x minus 1. Be careful. I would write it out because that always gives you a chance to double check your work when you go back. Personally, I like to line up the like terms. I think it helps. It's extremely helpful if you know your integer rules, because then you can do most of this through mental math. The calculator will not do this for you. It does not add variables. So you really have to do it yourself. You can use the calculator to do things like -12 minus 3 if you're not sure what the answer to that is. It will do the integer math for you, but it will not do the algebra. It can be checked, but only if there's one variable. For example, if I was to check this question, there's 2 ways that you can do that. So you type in the question, and you do have to type what's being subtracted inside a parentheses because you're subtracting that whole thing. So you would type the 4x squared minus 6 inside the whole parentheses. That's going to give you a number. And then basically you type your answer, and you just want to make sure that those numbers match. One easy way to do that is, before you actually check this way, store 10 as x. And this way, what you're getting is going to look very similar to powers of 10. Okay, another way that you can check this is to use the math test feature on the calculator by putting in an equal sign between the question and your answer. And if these two things are indeed equal, you will get a 1. If you get a 0, that means what you entered is false and you have a mistake. Good luck. Please do your practice and check your Google Classroom for the notes to check your classwork.